I'm Ed Amoroso from Tag Cyber, and it's my privilege today to be here with our guest, Irving Wladawsky-Berger, who is one of my personal heroes.
Well, thank you for saying
that. I'm so glad
that
you're here.
It's a pleasure to be here.
Oh, it's wonderful to be here. Hey, we're going to start by just asking you, tell us a little bit about your very illustrious career and some things about your person.
Okay, well, let me start by saying, as you might be able to tell from my accent, I wasn't born in Brooklyn. A little farther south, I was born in Havana, Cuba. My parents came to Cuba from Eastern Europe. They had a store. You know what happened in Cuba in 1959. So store was taken away and we all left, went to Chicago because my father had relatives. And then I went to school in Chicago and eventually got a PhD in physics from the University of Chicago. And in doing my PhD, this is in the 60s, I worked with one of the pioneers in the use of computers in physics and chemistry, Clemens Rotan. So when time to get a job, I realized I really enjoyed the computer part more than the physics part. So I then switched fields to computer science and went to work at IBM's Watson Research Labs.
What year was that?
This 1970.
1970.
So I joined IBM Watson Research Labs, which is in Yorktown Heights, about an hour
Beautiful place.
north of here. And I did different things in computer sciences there. I stayed in the research labs with various positions and management and so on for 15 years.
What was the initial project in 1970? Do you remember?
Yes. In 1970, we were looking at how to design multi-processing computers. And you could say, boy, that sounds primitive. But remember, computers in 1970 were very young.
Unix had just been invented.
Unix had been invented. In IBM, the bulk of the work was around mainframes, as you can imagine. And so we worked on that. A few years later, I did some work in artificial intelligence, which in those days, we'll talk about AI later, the work on AI in the mid-70s was the old model of AI.
The ELIZA program, remember that?
It was, yes,
at MIT?
It was the time when people thought that you could program in intelligence. And it was fascinating, and we should talk about this when we talk about AI in general. That approach didn't work. But anyway, I then switched over to start doing more work looking at the future directions of IBM products. And so we had a major research initiative on the future of large computers, and I was very involved in that. We had projects in the future of networks and just different things. And in 1985, I was leading computer sciences research in our labs, but then I was asked to come over to IBM's large system division, essentially to be in charge of large system strategy at the technology level, not at the financial level. So I did that. I switched over. I did that for a few years. I got very involved in supercomputing. And then one of the main things that I did in IBM in the late 80s, early 90s, is that, I don't know if you remember, maybe you're too young to remember.
No, I was around then.
That IBM came very close to going out of business. because of the major transition from central computing based on mainframes to client-server computers.
The Charlie Chaplin commercials with the little IBM PC.
Right.
That was quite a transition.
And Unix servers and things like that. And that transition meant that you could do a number of applications, not all, but enough to really hurt in client-server systems, combination of PC or Unix-based clients and servers that before required a mainframe.
Right.
And all of a sudden, the price of mainframes had to come down, gross profit margins came down, and IBM was in just terrible shape. And then I was working hard in my job with large system strategy with people from the research labs to decide how can we develop the next generation of mainframes based on microprocessors instead of based on the previous technology, which is called bipolar technology, which was a lot more expensive. And could we port over the software and parallelize it? Because the microprocessors were not as powerful. So that was a very, very important project, because if it hadn't worked, IBM would have pretty much gone out of business. I think different parts of IBM could have disaggregated, but we were successful in making that transition. It took a while. Lou Gerstner.
I was going to ask, it was around when Gerstner came.
Yeah, Gerstner.
And he'd been hired to basically dissolve IBM.
No.
Is that a myth?
No. The previous management of IBM had made the decision to partition the company because they didn't know what to do. That is the reality. They really didn't know what to do. We can discuss why is it that the same group of brilliant people, but when I say brilliant, these were really brilliant executives who built IBM to be, let's say in the mid-80s, the most powerful, profitable company in the stock market. How is it that those same people were not able to transition IBM into the future? The answer is, I've given graduate courses on this and so on, it's Greek tragedy. That the same stuff that makes you great will likely prove your undoing. I'm being
that's profound.
Frightening. I'm being totally serious that, and this happens in music, it happens in sports, it happens in
politics.
For sure, politics, that you become great by doing certain things really well, then the world changes. And when the world changes, you say, what the hell happened? I'm supposed to be here on 200 Broadway, and all of a sudden I look around and I'm not here anymore. And it just feels like a totally different planet. And this is very common, that the same management team that got a company to this level is not the same team to take it to the next. By the way, that happens with startups all the time. That the founder
is replaced
when you need to go to the next level. So IBM, the IBM board hired a person that in retrospect proved to be, in my opinion, one of the top strategists and executives
in Gerstner.
In Lou Gerstner.
With a consulting background, right?
Well, remember, he had an MBA from Harvard Business School, then he went to work for McKinsey, then he was the president of American Express for a number of years.
Capable, exactly.
Then he became the CEO of RJR Nabisco.
Right.
If you remember,
I do remember
all the machinations
Yes.
about the whole RJR Nabisco, and he came to IBM from RJR Nabisco. And he wrote an excellent book, Who Says Elephants Can Dance. And Lou wrote in the book that the board talked to quite a few other executives to see if they would come to IBM, and they said, why should I come there when the company is basically dead? I don't want to come to do that. And he said they twisted his arm by telling him that, this was such an important US company that this was like an act of patriotism. He wrote that to come and save one.
No, I read the book. It's one of the great business books of all time.
Anyway, so Lou came and he talked to customers. And the customers all said, Lou, we don't want you to split up IBM because the last thing we need is one more, we need help to integrate all the technologies that are not coming along. PCs were coming along, Unix coming along, we still have mainframes. And so we don't need 12, 13 little IBMs out there. We need one IBM that can help us pull these things together. There are things we want. We want you to lower the price of mainframes because you are no longer competitive. So we need you to do that. We want you to become more open instead of as proprietary. There are things we need to do. Lou listened to the customers. And first decision, we're not going to break up the company. In fact, Lou really bought into the strategy we had been working together to transition now the mainframe to CMOS microprocessors, that is industry-oriented microprocessors, still running the mainframe architecture, but by running the mainframe architecture and the mainframe software, that meant that the customers could port their application.
At lower cost, too.
At lower cost, because now you can build them out of microprocessor technology instead of requiring different technology. So we did that. He established a major services business, IBM Global Services, because customers said, services, we need the integration. So he did that. And then, and this takes me into the next stage of my career, after IBM was stabilized, and I would say Lou came to IBM in April of '93. And I would say IBM was in the emergency room for the next year and a half. But by 1995, it had stabilized. It was a very painful stabilization because in the old days, when IBM was at its height, the gross profit margins were 70% or higher. When you have those kinds of gross profit margins and when you have 70% of the market, you're making a lot of money.
You're making money.
And so IBM had gigantic expenses. We had tall buildings in every city. We had a museum in 590 Madison, which is the building. We had a lot of people. You had to get costs down. And part of it, also a number of the old manufacturing sites that you needed for the days of the mainframe, you no longer needed for the microprocessor. And so we had to lay off a lot of people. And we did. It was very painful. I think at the time, 93, 94, IBM took what may have been the biggest write-off any company had taken in industry. I think since then others
To re-level set.
to re-level set. But by 95, the company was stabilizing, and as Lou wrote in his book, now it was time to not just have IBM be alive. So you go to a party and people say, where do you work? And you say IBM, and people say, gee, I thought you guys were dead. And you say, no, we're still alive. You said,
Right.
we needed, that was good. That was a to move to the future, it's first necessary to
You
be
moved
alive.
out of
in
the emergency room
Yes.
into a stabilizing room.
Stabilize. Yeah, so we were alive, but now we needed to restore IBM to something good. And then, again, the way I think about it, the Greek gods sent us a gift, which was the internet. And the way I think about it is that they said, here is the internet. This is going to be a really big deal. Don't screw it up, because we can only help you this once. We didn't let you die before, but if you screwed this up, it's all over. And so Lou and people around made a huge decision to pretty much build the whole company around the internet and the open standards of the internet. Now, to talk about this in 2018 doesn't feel like a big deal. But if you know, as you do, the history of IBM, where everything was highly proprietary, that was a gigantic cultural change. And Lou asked me to come and lead the internet division. And so for the next 4 or 5 years, from December of 95 until the end of 99, I led IBM's internet division, and IBM really did well.
Right, I remember.
In the internet. I really think the internet helped us restore. And I think the key thing we did well, I'm sure we did a number of things well, but you remember the dot-com frenzy. And in the early days of the internet, everybody, and when I say the early days of the internet, literally speaking, was 60s and 70s.
Right.
I'm talking about
the World Wide Web,
the commercialization.
late 90s into the early 2000s.
The early days of the commercialization of the internet, which I think of it as the mid-90s when it started.
That's right.
There were all the dot-com startups and others saying, if you are a business and you have an established infrastructure, and even if you have physical stores, you're dead.
Yeah.
Because all these things are a noose around your neck. Now, as you can imagine, our customers think of airline reservations, think of banks, think of manufacturing companies with inventory management. If somebody comes to them and says, you have to get rid of all this, the answer is, we've spent, 20 years building these applications. We've spent billions with the infrastructure. What the hell are we going to do?
And they're proud of it, proud of that work.
Well, they couldn't imagine running their business.
Right.
And if somebody said, oh, no, you just buy a PC. Well, PCs are wonderful. but they're not what you need to run a transaction processing mission critical database. We came along and we said, no, our strategy is very different. Something called e-business. Well, we will marry the back-end IT systems, transactional systems, database systems, application system with the web.
Right.
And what that means is that now with a PC, with a browser, you can access all the data back there. just will make it work. So you can do transactions. So if you are UPS or FedEx and somebody wants to know where their package is, before the internet, they had to call an 800 numbers and read them a very long number of letters and things, which was a little awkward. Now, you go to a browser, you go to ups.com or fedex.com, you enter that number, and automatically the browser talks to a web server, and the web server in turn goes to the backend system.
That was revolutionary.
You don't have to rewrite the backend system. The backend system is the way it was, and you give them back an answer. We call that customer self-service. Now, again, in 2018, you can say, but Irving, that's a crappy little application, but it turned out to be an incredibly useful,
yes, it did.
Crappy little application. I mean, and this happened over and over, e-commerce. Our first e-commerce client was LL Beane. Well, before, LL Beane's still around, as you know. Before the internet, LL Beane, as Lansen and others, send you a catalog, and you look at the catalog, you decide what you want, you call an 800 number, and you talk to people. Now, you go to the llbean.com, the catalog is online, you decide what you want, you put it in. All of a sudden, but again, this sounds so obvious in retrospect, but it truly felt magical. That you could, that's why we had the dot-com frenzy, because
it was. I mean, look where we are now.
Yeah.
We wouldn't be here if there hadn't been that transition.
No, we couldn't be here.
From legacy and paper to actually being comfortable online.
And in fact, I view the onset of the commercial internet in historical terms, in the following sense that, everybody agrees that toward the end of the 18th century, let's say in the 1780s, we started the Industrial Revolution.
Right.
With steam power and all kinds of things. And then years later came railroads, and years later came electricity, and on and on and on and on. And of course, eventually got telephones, cars, airplanes, and so on. And the Industrial Revolution of the past 250 years was incredible. I mean, the number of things that get done. But when you look at the Industrial Revolution, all the advances were physical. We used technology to make up for our physical deficiencies. So we cannot go very fast. So we get railroads, we get cars, we get buses. That means we can go as far as we want to. We cannot fly. Guess what? We get airplanes. So now we can fly. We are not very strong. Okay, so we got steam power. Later on, we got electricity. So all of a sudden, through the Industrial Revolution, we developed all kinds of tools that essentially augmented human capabilities. Strength, speed, flying, whatever.
Right.
But then, starting, in my opinion, with the internet in the mid-90s, we started making up for, let me call it, our cognitive limitations. No longer physical, now cognitive limitations. So the internet came along, and now you can communicate with anybody anywhere, day or night. You want to buy a sweater at midnight? Be my guest. Go to LL Beam of Land's End. And you could say, well, that's not a cognitive limitation, but there were limitations of temporal things and so on. And that started us on a whole new journey, and we'll talk about this later. And all of these digital advances started to generate gigantic amounts of data. So we were able to now use that data for all kinds of new analytics and artificial intelligence tools. But what I really think, the reason I feel it's such a big deal is that just like in the late 18th century, we went from the previous agricultural age and feudalism and kings and popes. I mean, we still have kings and popes, but then that's all we had.
Less consequential.
Less consequential. Now we've been moving to a world where information and knowledge and the ability to build tools to help us enhance our information and our knowledge are incredibly consequential. And we're just at the beginning of this new era. I think of it as the digital economy. I don't know, some people may say it's an information economy or a knowledge economy. Historians will name it in the future, but it's very, very profound what is going on right now.
Now you've left us at 1999, the internet division, and then I presume Y2K came along.
Well,
what were you doing
I wasn't
at that
involved with Y2K, but by 99, the reason I was no longer involved in the internet division is we didn't need an internet division anymore.
The whole company.
The whole
an
company
internet
was the
division.
internet.
Right.
And we knew, in fact, from the
remember
beginning, that was our objective, which is, yes, we need an internet division to kickstart this. But your job is not to have a division separate from the other ones, was to help everybody in IBM embrace the internet and then move on. So my next job, I was very involved in Linux. So we made the decision, which again, in retrospect, was a brilliant decision, to embrace Linux across all of IBM.
More than any other company.
Yes, more than any other
Absolutely.
company. And again,
It was shocking to watch. I remembered IBM as an old proprietary company you guys.
But I think that once we had switched from proprietary to open because of the internet, embracing Linux was actually a natural next step.
Lotus Notes hung around a little while.
Yeah, Lotus Notes
That
was
did
there.
hang around a little bit.
Yeah, they were there and they ran on Linux
And
also.
they made money.
Yeah, they made money. It was an application doing things, but we embraced Linux, and I was very involved in doing that. And there were a few other things. There was something called grid computing that I was very involved in. Which
Before Linux was AIX. Do I have that right?
AIX, okay. Before Linux, there were multiple flavors of Unix that different companies had. IBM's flavor was called AIX. Sun Microsystems flavor was called
Unix
Solaris.
System 5 at AT&T, right?
Then HP had HPUS.
Right.
Digital DEC had whatever. And they were all variations of Unix, but each was a little bit different.
Linux was better.
Well,
It sort of took over. I mean,
it took over for a couple of reasons. The first one is that, let's say that in every borough of New York, people speak a variation of English. And
which is probably true, right?
yes, but for the most part, we can understand each other.
True.
And if maybe that's a little too local, you can say across the US,
Across the US,
and you couldn't. And in fact, porting an application from Solaris to AIX required quite a bit of work.
Yeah.
Now you could say, guys, these are all variations of Unix. Why don't you get together and develop one Unix? We couldn't do it because of competitive thing. So Linux comes along, developed by, at the time, this young Finnish computer scientist, Linus Torvalds. And it's open source, meaning it's available to everybody. Linus could have patented it or whatever, and maybe he would have made a lot of money.
Berners-Lee, same thing. The two
same
of them,
thing.
yeah,
You know, they were, here it is, go do it. And then all of a sudden, you had this open source version of Unix that they invited the best and brightest to contribute to. That's what they did, and Linus Torvalds, and they had a management based on maintainers and different things, and they put out releases. But that totally transformed the way software was built.
Yes.
And moreover, because Linux was being worked by different people from different companies, many of them were not in any company, it had to be much easier to read. It had to be better structured. So it was easier to change, but part of it, the combination of being better structured and open source meant getting Linux to work on different hardware architectures was relatively simple. Right. So one day, I don't know, in 2000, we found out that some engineers in IBM's lab in Böblingen, Germany, which is a town outside Stuttgart, had ported Linux to the mainframe. And so we had Linux on the mainframe. Now, if you had said, well, could you have ported AIX to the mainframe? In principle, we could have. It would have been a gigantic amount of work.
Or you would have emulated it somehow.
God knows what we would have done. No. But in fact, we had a project to try to do that. It would have been difficult. This was done by a couple of engineers in the equivalent of over a weekend. Maybe it was a little longer. And in fact, I remember having...
Those are the best projects, right?
I remember having lunch with an executive from SAP, and their headquarters are in Waldorf, Germany, not far from Böblingen. And we were talking about this, and he said, you know, when I found out that your guys here ported Linux to the mainframe, I thought they'd be fired. Because how can you, you know, it's like, how can you, quote unquote, desecrate the mainframe? And I said, no, we made them heroes. Because now you can buy mainframes which have, the hardware of mainframes has many good characteristics for industrial strength, but now it can run Linux applications. And IBM sells a fair, to this day, a fair percentage of mainframes to do Linux. But you can port Linux, obviously, to PCs in an easy way, to different architectures. And of course, as we know, you know, Google's Android is a variation of Linux. iOS.
Even Windows.
Well,
it's in there.
It's in there, probably more going back, not Linux, but before.
Yeah.
But
the POSIX.
Yeah, I think it probably goes back to the AT&T. But it was a new world where you know, the way I think about it is the nature of competition had moved up the stack. It was less important what you did with individual technologies than the applications.
Right.
The innovation was now much more in the applications that you were supporting, and getting into a debate about an operating system that most people could care less about didn't make any sense. So if that's the nature of competition, you may as well join the open source movement and get Linux for everybody and compete at the next level, which is applications on Linux. Like in IBM, it was WebSphere and different applications and so on.
Was Mr. Palmisano the CEO around this time?
Yeah, in fact, he became CEO shortly thereafter. And I was, again, I worked closely with Lou Gerstner when he was CEO, and I was working closely with Sam. And then one of the last things I did in IBM, first we established an initiative that at the time we called on-demand computing, which we did this like 2002, 2003. And at the time, on-demand computing was essentially a precursor to what became cloud, which is people could have
shared service.
Yeah. And I think 2002, 2003, the market wasn't ready, is the reality. And it just wasn't, we did quite a few things, but the market wasn't ready. It took another 5 years for the market being ready for cloud, but at the time it wasn't. And then my last few years at IBM, I was we had something called the Ibm Academy of Technology, and I was the chairman of that, and I was in charge of university relations. So I had a few positions that one has toward the very end. And then in 2007, I retired from my full-time job at IBM, and I remained as a consultant to the company until December of 2011.
And you do some writing now as well.
Well, then, so in 2005, IBM started a major initiative around social media and blogging and things like that. And our head of communications, Gianni Wada, said, Irving, it's a little embarrassing if we have this social media initiative and we don't have any senior executives involved. So we'd like you to start a blog. And I said, well, I didn't know if I wanted to do that. And he said, well, we need somebody. And we talked and we thought something that you would enjoy. And sometimes you do one for the Gipper or whatever. So I said, okay, I'll try. And so I started a personal blog my personal blog in May of 2005. And as it turned out, I actually enjoyed it a lot. It took me a while, and it took me a while to figure out what to do, but I've been pretty much posting a blog, a new entry in my personal blog every week since 2008.
Right.
And then in April of 2012, the Wall Street Journal, CIO Journal, started a new online edition called CIO Journal.
Right.
And they reached out to me and they said, we would like you to be a guest columnist here. And we would like you to publish a weekly column. And we talked about it. And I said, I don't think I have it in me to write one column for my blog and one for the Wall Street Journal, because it's not that easy to write. And, and I spend quite a bit of time, but we made an arrangement where I publish, the way the arrangement has worked out, I generally post my blogs on a Monday, and then CIO Journal their editors will look at it, do some editing if they want to, which they often do. They maybe shorten it or whatever, and they'll post it on the Wall Street Journal, CIO
For
Journal
all of us.
on Friday. Well, you can.
I know, either way.
Either way, and that's been going on since 2012.
Yeah.
In 2005, I became involved with MIT, and I'm still quite involved with MIT. I've had I'm pretty much a visiting faculty member and research affiliate in the Sloan School of Management, and I'm a fellow of two major initiatives in MIT, the initiative on the digital economy, which is in the Sloan School led by Eric Brynjolfsson and Andy McAfee, and MIT Connection Science, which is in the Media Lab led by Sandy Pentland, and that's been going on. I've spent time at Imperial College in London, although now I'm doing less there. After I retired from full-time at IBM, I consulted for Citigroup for 6 years. I consulted for HBO for 1 year and for MasterCard for 2 years. Mm-hmm. So that's sort of my long career.
Well, it is an amazing one. I want to talk some big thoughts with you, because I know you think big thoughts. Let's start with artificial intelligence. Mm-hmm. What do you think?
Well, first of all, it's very important to just look at the history of AI, because artificial intelligence as a discipline harks back to the 50s.
Von Neumann.
Well, von Neumann, but even I think the real, it was really after von Neumann, probably the pioneers were people like Marvin Minsky at MIT and Seymour Papert at MIT.
They actually built things.
Yeah, they built things, and they had a whole faculty, department. And at the time, the approach to artificial intelligence was that we would try to program the computers using specialized languages like Lisp. Mm-hmm. It's an example of a language. Prolog was a language that came later.
These logic languages.
Yeah, these are essentially logic languages. And then that's how we'll program intelligence. Here is the problem. You cannot programming something with a programming language requires you to understand what you're programming to a great degree. So if you're going to program a mathematical calculation, you have to program the goddamn calculation.
Right.
And I did that for my thesis, for example, written in Fortran. I don't know if anybody uses Fortran.
I used to when I started.
Anymore?
No,
but
nobody anymore.
you program, so I would call that more deterministic programming. You have to know, this is the problem, let's design. If you want to design a banking application, this is what the banking application does. You come in, you put your ATM or your passbook. I don't think anybody has passbooks anymore. This is what it does. It goes to your account, it gets back. Right. Somebody has to write that in a programming language. But if you said, okay, now program a navigation application to get you from here to your home in Connecticut, I don't know what to do, because that's not like a banking application or a mathematical application. That's a different kind of application. And people felt, well, Irving, it's just a matter of waiting for computers to get fast enough. And they felt, the pioneers, that this is, let's say, in the 60s and 70s, within a generation, computers would get powerful enough that we could apply AI programming to get applications with intelligence roughly equivalent to humans. Right. Within a generation, let's say 20, 30 years. They were wrong.
Yeah.
The problems turned out to be much, much harder than anybody thought. And by the 1980s, that approach to artificial intelligence pretty much fell totally out of
It blew
favor.
up in complexity, right? These combinatorial complexity of choices that you couldn't think that way.
You couldn't. We
No
just
logical structure. To
we
that.
just didn't know how to do it.
Right.
That's the thing. Japanese actually in the 80s had a major program called the fifth generation computers to build intelligent machines. Everything failed. And in fact, there was something called the AI winter. And if you watch Game of Thrones, I don't know if you know, in Game of Thrones, people keep saying winter is coming. And winter is coming is not a good thing, because it's not just winter is coming.
People still talk about AI winter.
Yeah, well, AI winter meant that all the government support dried up because the thing wasn't going anywhere. But lo and behold, in the late 80s and 90s, something happened. In physics, in high energy physics, in astronomy, people had been working, analyzing data for a very long time. If you look at high energy physics, sort of, what does it mean to find the Higgs boson? Well, you build this incredible accelerator in CERN, Geneva, and particles clash against each other and produce gigantic amount of data. And then you have to analyze that data very carefully, and you're looking for the equivalent of a needle in a haystack. That if you find the events you're looking for, you found the Higgs boson, and in fact, a few years ago, people found it. But to do that kind of very sophisticated data analysis against gigantic amounts of data, the scientific community had built parallel computers and all kinds of algorithms and so on. And what they were really doing, another example I like to point out, we've heard a lot about finding exascale planets. That is, planets in stars outside the solar system. And what you do, there is something called the Kepler Telescope that looks at all these stars and gets a lot of data. And the way you find a planet is that here is this star, and then there is a little dark thing that passes by it. And based on characteristics of that little dark thing, how big it is, whatever, you can then begin to infer it's a planet, how close is it, blah, 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 blah. But again, it's based on analyzing a lot of data. And on, analyzing gigantic amounts of data has been, decoding the human genome, genomics. So there has been a lot of experience. And in fact, people in marketing had already started doing something called data mining, where you get information about what products people are buying, and then analyze that to try to predict
marketing
what they are going to buy. But then in the 90s, people started applying these kinds of brute force data mining techniques to get patterns in the database that would let them predict what is likely to happen, to learn what the data is telling you. And all of a sudden, instead of programming intelligence, which we didn't know what to do, you were extracting features out of the data that were the equivalent of intelligence. And a major example of that was Deep Blue, which was a supercomputer that IBM built in the late 90s to play chess.
Right.
Now, playing chess had been one of the holy grails of
course,
AI.
Sure.
And again, if you try to play chess, but programming how to play chess, nobody knew how people play chess. But the way Deep Blue was built is they got gigantic amounts of data about previous chess games. And they knew precisely, based on this board configuration, these are the moves that previously were done that resulted in a better position versus other moves. So all they were
Completely different way to do algorithms.
totally different way.
Right.
It was really
Actually
pattern.
a dumber way.
It was dumber. It was dumber, exactly. It was dumber compared to the way people do it. But remember, at some level, it was perfect for a dumb machine.
Yeah.
So it's, you say, well, this machine is intelligent. No, this machine is a goddamn machine. When you put data and algorithms in the goddamn machine, then it becomes intelligent.
It looks intelligent.
You have to put applications that are suitable for a dumb machine.
Yeah.
And it turns out that one of the things that kept happening in the 90s, and of course far more now, is these machines were getting faster, microprocessors were getting faster. We were learning how to aggregate them in larger and larger numbers with parallel computer. Storage technology was getting much cheaper, so you can store huge amounts of data. So a few things started coming together. Let me repeat. Faster and faster computers with cheaper and cheaper storage, with lots of data, with sophisticated algorithms to analyze data. And all of a sudden, and I think Deep Blue was a major step in this direction, Deep Blue beat Garry Kasparov.
I remember most famous chess match ever.
Yeah, in the world. And I think he lives now in New York.
Right.
He's moved from Russia to New York. And it did that, I think, 6-1 or something. I mean, it was shocking.
In the computing world, it was the equivalent of the worst team winning the World
Yes,
Series.
it
You would
was.
have never expected it. That was exciting.
It was totally unexpected because that was the proof point that this technique
that it
worked.
would work.
Now, since then, there have been gigantic advances in those techniques. We have Google search, which is a variation of huge amounts of data, sophisticated algorithms, ask a question, it finds it. One example that I love, because having been born in Cuba, I like baseball a lot,
Me too.
that comes with the territory, is the whole world of Moneyball. You know what I'm talking about.
One of my favorite books.
Billy Beane, and all of a sudden, starting with the work of Billy Beane and others, I think
He was the pioneer.
he was the
Oakland A's.
the Oakland pioneers. Also, the book Moneyball was about him.
Right.
So that also
Made him famous.
Made him famous. Yeah. So it became great, and then so all of a sudden you can start applying these kinds of statistical analysis to help you decide which players you should be drafting based not just on your intuition, and intuition is okay, but looking at which players with certain characteristics in the past did best, and now which of the players you are looking to draft have these characteristics.
Right.
And you are matching patterns and say, well, then this looks like the kind of player Remember, it's all statistical, that it's more likely
sure.
to do better.
Actually, in the book, it goes further to imply that your intuition is bad.
Well, I think
Maybe that's wrong.
no. The movie in particular tried to portray this because it was dramatic as a fight between the
old
scouts
and the
and the
computers.
nerds.
Right.
The reality is that, and I think most people will agree
Yeah.
now,
The
you need a
confluence.
combination.
Yeah.
You know,
I think that's right.
and in fact, in fact, I don't know if you can survive as a scout today if you don't make use of these tools.
Yeah.
So just about all teams make use of it. And in fact, I recently read some very good articles about Jeff Lunau, who is the general manager of the Houston Astros. And McKinsey did a series of interviews with him to find out how did the Houston Astros go from having lost 111 games in 2013 after losing over 100 games in 2011 and 12 to winning the World Series in 2017, and they're doing very well now.
Yeah.
And the answer is they hired Jeff Lunau as their general manager in 2011. He came from the St. Louis Cardinals, where he was in charge of player development, and he had used extensive analytics to do all this stuff. And the articles were great that it took him a couple of years to convince the whole organization, not just the Astros at the major league. Remember, baseball, you have minor league teams, you have teams that are scouting for players in the Dominican Republic and different countries. They all had to buy into this.
Right.
And that took him a few years. But once they did, it changed the game.
The geeks taking over baseball.
Yeah,
in a
but
sense,
but you need the combination.
You
You do need the combination. The Yankees, by the way, are considered one of the very good teams in analytics. Brian Cashman is good. The Red Sox
obviously
are very good at doing that. And now all teams, one way or another, are embracing analytics.
You know, let me ask you. So this theme of technology having a fundamental impact on something has also happened in industrial control, hasn't it?
No question.
IoT, industrial. That's an area you write about a lot.
Yeah.
What are your thoughts? Do we see the same thing happening on the factory floor that we see on a baseball field?
Well, so on a factory floor, you want to get as much information as possible about what's happening.
Because remember in the 90s, the Japanese said the way to optimize a factory floor is to have the human beings work together and to remember Theory Z and you empower the humans and anyone can stop the line.
Quality circle.
Right, remember that?
Yes.
And now, who talks about that? Now we talk about a computer doing it.
But
is it the same thing or is that crazy?
No, it's not crazy. And in fact, the reality is that IoT is one of the most fascinating strategies, which essentially is about make everything around you smart. And smart, in the sense we're using it, means nothing more than make sure it has a sensor, it gets information about what's going on, it transmits the information where it then can be integrated to figure out what's happening in the factory.
Right.
And people have been applying these kinds of smart infrastructure, smart system techniques for manufacturing, smart cities, for machinery. For example, every jet engine is full of sensors these days. And as the plane is flying, it's transmitting information to whoever manufactured the engine, whether it's GE or Pratt & Whitney or Rolls-Royce. I think those are the three top jet engine manufacturers in the world. And by getting that data from the engine, they can analyze it and figure out, is everything okay? Does the plane need to go for maintenance? If it needs to go for maintenance, when? If there is a problem while the plane is flying, do you need to land the plane because it's a serious problem? Or is it the kind of problem that you can keep going and we'll handle it once you land? And if it's one that you can go ahead and land, does it need to be taken care of right away, or can it wait to the same maintenance? Mm-hmm. And the same is true for elevators, for energy turbines.
Sure.
So pretty much
automobiles.
Yeah, but this has been done first for really expensive equipment, like jet engine and things like that. It's coming to everything else, but initially it was done. And that's a very good example of this whole notion of smart, because it means when you are now designing the thing, one of the things you are designing is the right sensors to tell you what's happening. And then once you get the data, you can analyze it and make predictions. Mm-hmm. Now, is that artificial intelligence? Is it analytics? The way I think about it, and this is a very important statement, it's very good engineering. This is the way I think about it, and I'll explain why I'm saying that. If I tell you if an elevator is likely to break in 5 days, would you rather know it now or wait until after it breaks? That's an obvious. Obvious. And if the elevator is designed to help you anticipate when is it going to break, do we call that a human-like intelligent elevator, or do we call it a well-designed elevator from an engineering point of view? The reason I'm being a little pedantic is because artificial intelligence has the name intelligence in it. And then part of artificial intelligence is, of course, robotics. And robotics has played roles in many science fiction movies. Going back to HAL in 2001, which I don't know.
And every Twilight Zone episode had a robot that became humanoid.
I don't know if you've watched Westworld.
Sure.
And have all these robots, which are so. And of course, there is the other side of sort of more this human-like intelligence, which is, will there be any jobs left? We can design machines that are human-like in their intelligence. Somebody can say, well, next time you're doing an interview like this, why interview Irving? You will interview a robot with all the knowledge in the world. As it turns out, that kind of human-like intelligence is science fiction. It may not be science fiction 50 years from now. It's definitely science fiction today. And anybody who knows, for example, we've made huge advances in robotics. In Westworld, you would say, well, they look all like beautiful women. And so no, they look like a goddamn machine on the factory floor that is welding things in the car, or, it's a machine. It's just, why is it a robot if it's a machine? Well, because it has intelligence. Let me give you an example of a robot, a self-driving car. What does a self-driving car look like? It looks like a goddamn car. Because the last thing The one is a self-driving car that looks like a person.
Right.
So
Makes
it
no
looks,
sense.
So in every, but of course the picture you get is always the machines and the humans. In fact, when you look at the huge advances we've made with artificial intelligence in the last few years by applying very sophisticated algorithms called machine learning and deep learning, which we can talk about, it's all exquisite engineering. It's all really good engineering. And it turns out that by applying this kind of deep learning, look for patterns, extract the patterns, analyze data, you can teach a machine to recognize cats in pictures.
Right.
You can teach a machine to recognize people in airports for security reasons, which is happening more and more. You can teach machines to understand spoken language. Now, the machine, if you say, well, does the machine really understand? That's a philosophical statement.
Well, Dijkstra said that asking whether a machine can think is like asking if a submarine can swim. Remember? It's like that.
Exactly. Yeah. The fact is, you say, hey Siri, what time is it? And Siri will understand and answer. Now, does Siri know? Now we're into...
It's metaphysical.
Yeah.
Hey, let me ask you, we're getting close to time here. I want to ask you something about the future. So, a lot of technologists, and you know I work in cybersecurity, a lot of technologists posit that whether it's artificial intelligence or hackers or whatever, are leading us toward some very bad things that are technology driven, meaning when they think about the future technology, they think, wow, we need to be fearful.
No question.
What do you think?
I think they're absolutely right. But again, getting back to engineering, how do you make sure planes are safer? Well, you do huge amounts of work about what causes planes to crash.
Right.
And you keep designing more and more techniques and methodologies and so on to make planes
and over
safer
time
and
things
safer.
get better. They'll come down the experience curve.
Yeah, it's far better now. Now the reality is that the digital world, remember we're early in digital world, has run far ahead of our ability to do identity management, of our ability to secure data, of our ability to make data private. The data part of all this, big data, 15 years, would you say? I mean, we only had big data once the internet take off.
Well, telecom, we were pulling terabytes of data. That's not petabytes, and that's something bigger.
So now
we weren't calling it big data.
No, certainly. Because it wasn't big data compared to the amount of data we have now. And by the way, it's not just technology, government policies. I mean, I just finished reading a very good article about identity management. And if you said to me, well, Irving, social security number, that's a great way of certifying your identity. Our social security numbers are everywhere.
Right.
That's a crappy way. That may be a fine way to identify you, but not to authenticate you.
It's not even a great way to identify you.
But identify you, nobody's going.
Right.
Nobody's going. If I wanted to get in here, and I tell this young woman, here's my social security number, she would know, why the hell are you telling me that? So that's not a very good way. But what we need, to get a social security number or associated with your social security number, the Social Security Agency has huge amounts of data about us. What we need is for them to help certify your identity to the right people as needed. Because they can answer questions about era moroso based on their data as part of a general identity certification. So can DMVs, the Department of Motor Vehicles. And then the private sector can do all kinds of conglomerations of data to certify identities. The part of the work that I'm involved in with, at MIT with Sandy Pentland in the Media Lab is the fact that identity is really based on all the attestations, all the data we have about you. And the more data we have, the better we can certify that era moroso is era moroso. Right. And so what is needed is to develop the right frameworks of ecosystems that collaborate in certifying your identity. And of course, in authenticating your identity based on the data. We have new techniques that will help us do that, like blockchain technologies for sharing databases and other things. But the reality is that because the digital, we think, well, everybody has a smartphone, that means the digital world is done. No. Everybody has a smartphone. The question you're asking, how safe is this digital world, is a different question whether That's everybody right. has a smartphone, and we are barely there. I think, again, important to remember, in the early days of airplanes, a lot of them crashed. In the early days of bridges, a lot of them fell down. In the early days of skyscrapers, they didn't do so well with earthquakes and things like that. We are in this ad hoc stage. And the ad hoc stage evolves into the really good engineering stage over time when we learn how to do.
So that's positive thinking.
I feel very positive that this will happen. It requires the collaboration of the research community, the private sector, and government. There are people that may say, well, I don't want government to have anything to do with it. You cannot do that.
Right.
That would be like saying, I don't want government to handle birth certificates and death certificates. Well, good luck. I mean, that's...
You need someone to do it.
Someone has to do it.
And that, by definition, is government.
Well, who else are you going...
Right.
I mean, pick your favorite technology company.
Well, government is human-made. It's created to do things that we need done. And when we create it, it's government.
Yes. And if you ask me now, do we want checks and balances on government? Absolutely. And I don't mean just government does it. I mean, government does their part, but, data about financial transactions, that's not government. That's whoever you're dealing with, your bank or your investment house or whatever. If we're talking about medical data, that's a different. We're not saying we want government to be the manager of all data. We want, in fact, part of the work at MIT, which is very important, is you never move the critical data to a central place.
Right.
You must leave it where it is.
Decentralized.
And then you have agreements with the owners of the data to answer questions about the data. Is it true that Irving was born in Cuba? They will say yes or no. Or they may say, I hear Irving was born in, Puerto Rico, Sierra Leone, Brooklyn, Havana, whatever you do, and they will just answer, but the owner of the data has the data and makes the agreement, and a major owner of data is government. There are also major issues like liabilities. And I've talked to financial institutions that would like to be identity service providers. And remember, it's all statistical. It means sometimes you'll get it wrong. And if you get it wrong, are you incurring unlimited liabilities? No business wants to incur unlimited liabilities. So we need some policies to help us manage this question of liabilities. It's all doable. Blockchain technologies would help. Very strong encryption would help. You know, we have a set of technologies, but that's why the cybersecurity work you're doing is so important. This has to be done as an ecosystem.
Right. I would agree. It's great to hear a positive message.
Oh,
We hear so much negative all the time.
I feel, you know, these are tough problems.
They are.
But I feel we can do this. There is no question.
I agree. Irving, I want to thank you for stopping by our studio to speak. It was such an honor to speak with you.
It's been a
I
pleasure.
think we
talking
can
to
all
you.
in the room here listen to you for 4 or 5 hours, but we run out of camera battery if we keep going much longer. But thank you so much for coming
Pleasure
by.
being
It was
here,
wonderful
Ed.
speaking. And we will see you next time.